Welcome to Siddhartha Institute of Science and Technology, Puttur. Good morning to all of you. Myself, Lakshman Sudhir. Today, I would like to tell about function generator. So, before we are going to the function generator, what is meant by generator? The generator is nothing but it provides the different types of output waveforms. That is either sinusoidal signal waveform, or square waveform, or sawtooth waveform. So, that is the definition of generator. So, it provides the different types of output waveforms. So, now we can see to the function generator. So in the function generator, it provides the different types of waveforms, that is sinusoidal, square waveform, and sawtooth waveform. So in that function generator, we can observe two types of waveforms at a time. So how we can observe that two types of waveforms at a time by using the function generator, we can see one by one. So before we are going to the explanation of function generator, we should know about the what are the components we are used in the function generator, or what are the blocks. So when you are observing the circuit diagram of function generator, the blocks are frequency control network, external frequency control, upper constant current source, lower constant current source, integrator, and comparator, and the resistance diode shaping circuit. So now we can see one by one component. So what is that external frequency control? So that external frequency control is nothing but it is controlled by with the help of varying the capacitor in the RC circuit or LC tank circuit. And one more thing, the same frequency is controlled by with the help of varying the current sources of the upper constant current source or lower constant current source of the varying the increasing and decreasing of the currents to the integrator. So with the help of these two, we can varying the frequency. So now, once the upper constant current source will be on, means the upper slope will be rises from positive to some peak value. Once it reaches the peak value, and again lower constant current source will be on. Once the lower constant current source will be on, means will be decreases, so up to some level. So depending upon the upper constant current source and lower constant current source, the output will be appear. So that means positive and negative cycle of the corresponding signal. So these upper constant and lower constant it is connected to the integrator circuit. So by using the integrator circuit, always it can produces the square triangular waveform. So with the help of capacitor means charging and discharging position. So once the triangular waveform is reached, and when the output of integrator circuit is connected to the voltage comparator, it comparing the two levels with the integrator. Then the voltage comparator output produces square waveform. So this is act like a switch circuit. So when the switch is connected to voltage comparator, then the output of the comparator always produces the square waveform. And same similarly, when the output of integrator circuit is connected to the resistance diode shaping circuit, then it can produces the sinusoidal waveform. So when you can observe these two outputs, we are giving with the help of amplifier section. So what is that amplifier means? The weak signal should be converted into strong signal. So sometimes the signal is converting or transferring from one block to another block. The signal may be lost. So for that purpose, we are using the amplifier section. And the function generator produces the different types of waveforms. And the frequency is few hertz to several hundred kilohertz. So mainly the function generator depends upon the integrator circuit. So that integrator circuit provides the triangular waveform. So how that integrator circuit provides the waveform means with the help of capacitor. So when the capacitor will be charging and discharging means with the help of positive current and negative current. That means increasing and decreasing currents. So when the current is increasing means upper constant current source will be on. When the current is decreasing means lower constant current source will be on. So how that upper constant current source will be on and how when the lower constant current source will be on means it depending upon the frequency control network. So that frequency control network is depending upon the two methods. One is RC circuit or LC tank circuit. And another one is increasing or decreasing of the currents on the integrated circuit. That means charging and discharging position. And main one thing is it having one phase locked loop. So what is that phase locked loop means one function generator locked with another function generator. Then it can produces the two waveforms at a time of the same phase. So this is about the function generator. Now I can see one by one point that it produces different types of the waveforms of adjustable frequency. Adjustable means varying the frequency. And what are the common output waveforms we are already discussed? Sine waveform, square waveform, triangular waveform and sawtooth. And the frequency is few hertz to 100 kilohertz, several 100 kilohertz. So these are the main. So now you can observe that fourth point, the various outputs can be made available at the same time. So at the same time, various outputs will be available. And now you can see that. So we are already discussing the integrated circuit is the output is minus 1 by c integral 0 to t into I into dt. So depending upon the upper constant increasing of the current and lower constant of the decreasing current, the capacitor will be charging and discharging position. Similarly, the frequency is controlled by varying the capacity in the LC circuit or RC tank. So that means by varying the magnitude of current which drives the integrator. So that means increasing of the current or decreasing of the current which drives the integrated circuit. So that integrated circuit always provides the triangular wave. That integrator output is connected to the maybe voltage comparator circuit or resistant diode shape. If you can connect it to voltage comparator circuit means it can produces the square waveform. If you can connect that given to resistance diode circuit, it can produces the sinusoidal waveform. Same, increasing or decreasing the current. This is about the function generator. So the comparator output is the square waveform. Mainly the resistant diode shaping circuit means the slope of the triangular waveform is changed. So that means alters means changes. So because why it is triangular waveform have to change means the integrated circuit always produces which type of waveform? Triangular waveform. That's why the slope of the triangular waveform is changed with the help of resistant diode shaping circuit.